So here are the notes for section 1.8, and this is the word problem. Now we've kind of dealt with these type of problems when an object is dropped. We know h, which is our height, equals negative 16t squared, where t is your seconds, plus h naught, which that's your initial height. But now we're going to talk about when objects are launched. Once again, h is your final height. Negative 16t squared stays exactly the same, where t is your seconds. Now if you look here, this is v naught times t. This is what we call your initial vertical velocity. So whenever they say here's your velocity, that's basically what you'll put here. And once again, h naught is just your initial height. So let's go ahead, let's solve this problem. Example 5. It says a juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial vertical velocity of 40 feet per second. The juggler catches the ball when it falls back to a height of 3 feet. How long is the ball in the air? Well, first of all, what we need to do is find our equation. So we need to find our equation. So let's go ahead and let's write that out. So we know we're going to have h equals our negative 16 t squared plus our v naught times t plus our h naught. So our h is where the juggler catches the ball, and it looks like he catches it at the height of 3 feet. So we're going to put 3 in for h. Now remember, negative 16t squared, that never changes. Now v naught, remember, is our initial velocity. Now it tells us that our initial vertical velocity is at 40 feet per second. So all we have to do is plus 40, because that's our v naught, and then our t stays exactly the same. Then we have, so let me make that so it looks like a t. There you go. Then plus our h naught. Remember, that's our initial height. So it says the ball leaves the juggler's hand 4 feet above the ground. That's what we call our initial height. So that's going to be our 4 here. So all we're going to do in order to figure out how long the ball's in the air is we're going to solve for our t, the seconds. Okay. Well, now remember, since we're using quadratic formula, we need to set our equation equal to 0. So in order to do that, we need to move the 3 over. So we subtract 3 from both sides. And so now we have 0 equals negative 16t squared plus 40t. And now we have plus 1. So plus 1. And this is a t here. Okay. So now what we're going to do is use the quadratic formula to solve. So remember, the quadratic formula is as so. So we have x equals negative b plus minus square root of our b squared minus 4 times a times c all over 2a. So let's list this. So we want to know what our a value is, which looks like it's at negative 16. Our b value is at 40, and our c value is at 1. So let's go ahead, we're going to plug these into our formula. So we now have x equals, and then we have negative 40 plus minus, and then we're going to have 40 squared minus 4 times our a value, which is negative 16, and then times our c value, which is 1. And we put all of this over our 2 times our a, which is 2 times negative 16. Now what I would like you to do is go ahead and pause this video so then you can calculate this and then see if you get the same answer as I do. So go ahead and pause the video so then you can find the answers. So hopefully you pause the answer, or pause the video to get your answers. Okay. So here are the 2 solutions you probably gotten. So you got x equals negative 0.025, and then x equals 2.52. Now, it does not matter that we changed our t to an x. If you want to keep it t, you can. If you want to keep it x all the way, that's fine. Now remember, we're trying to find how long. So the time it took for the ball to hit the ground, okay, or how long it was in the air. So remember that negative seconds or negative time does not make sense. So in this case, we're really only going to have one answer. And that one answer is going to be the 2.52, and we're going to say seconds because we need a label. And that's really going to be our solution here. Okay. If you have any questions on this, make sure you come in before or after school or email me. Okay. Now, you could also use a different way of doing this if you did not want to use the quadratic formula. Another way that you could do is using actually your graphing calculator to find your x-intercepts. So let's go ahead. I'm going to teach you that really quick. Okay. So we still have the negative 16x squared, which is fine. Now our initial velocity is at 40, and once again I need my x. And then we're going to have our plus 1 here. Now make sure your window is big enough for this, so I would say I'm just going to go to negative 100. Actually I could probably do negative 10 here, so I'm going to clear this and do negative 10. And then go to probably negative 50. Oop, I need to make sure that's a positive 50. And then I'm going to make the scale as a 5. And then here I'm going to do the same thing. So negative 10. And then I'm just going to go to let's say a positive 50. And make that, once again, 5. And so let's go ahead and graph this. Okay. Now, as you can see, this is probably not the best, so we can kind of change this up so we make sure that we have it all good. So I'm going to go back to my window, and let's make this 30. Still going to go by 5s. Okay, actually, let's go here and let's make it a 5, and we'll go by 1s. And I'm going to make my x min a 0 because we are needing only the first quadrant. And then here I'll make this 30, and then let's go ahead and graph it. There we go. So once again, remember we are trying to find our x-intercept. So in order to do that, if you need to make a sketch to help you to do this, that's always a good idea. So we know we have this here, and we know it kind of goes something like this, okay? So our x-intercept's right here. Remember, you want to draw a line that goes right through your x-intercept. And what we're trying to find is our left and right bound. So our left bound is anything to the left of our red line here, so that'll be our left. And then anything to the right side of our red line, that's going to be our right bound. So let's go ahead, let's put this into our graphing calculator. So remember, you go to second, trace, go to 0, and press enter. Remember, left bound, we need something that's above basically our x-axis. So we press enter. And then right bound is anything below the x-axis here. Remember, guess you press enter one more time. And it looks like here we get 2.52. And since we're rounding to the thousands, we got the same answer. So you could use both your calculator, or you could use the quadratic formula to find your answer. And that's basically how you'll find this, the answer to this word problem.